Hello, this is Paul from Force Tech. In this video, let's prove Theorem 4.9.3, interpretation of a rank and the nullity of a matrix. The result says a rank of a matrix equals the number of leading variables in the general solution space of a homogeneous linear system, AX equals 0. The nullity equals the number of parameters in AX equals 0. Okay, and this give us a meaning what rank was the nullity mean. Let's see why. First, we have to use the Gaussian elimination. Therefore, we need to reduce the row echelon. Let's say, okay, and the R is to reduce the row echelon of matrix A. We need the leading ones. So let's set up R be the leading ones of R. So R is the leading one, and if I look at AX equals 0, leading one means corresponding to the leading variables. Therefore, R should be the number of leading variables, right? So, okay, they are the same. And then we can look at the rank of A. What the rank? The definition of the rank should be the dimension of the row space, right, or the column space. We use the row space. Okay, that's the definition. The row space equal the row space of A equals the row space of R, because the row operation never changes the row space. So I can put, okay, so this is true. Now what's the row space? What the dimension of the row space of R? Depends how many leading one. We have a result before. It says the rows including leading one should be a basis for the row space. Now we have R leading ones, therefore R variables in the basis, so the dimension should be R. Okay, and therefore this equals R. What is R? R is the number of leading variables in the homogeneous linear system. Okay, so therefore we definitely find that the rank means the number of leading variables in the general solution of AX equals 0, right? So that's true. And then we look at B. What is the nullity? The set nullity is number of parameter. Okay, similar. First, what is the nullity? The nullity defined by dimension of the null space. Okay, this is the definition. So now we think about what the null space of A. The null space. Okay, the null space is just the solution space of AX equals 0, right? Or another way, we have a result. Okay, the nullity equals the dimension equals the column of A minus the rank of A, right? Okay, so or I put it in this way. And we did this before. So N is the number of columns of matrix A, and then minus the rank of A. The rank of A is R. So therefore, the column minus the rank. This is the dimension of the null space. What does this mean? This exactly means the number of the free variable, because our leading variable, total variable is n. The total variable, the number of the total variable minus the number of the leading variable. Therefore, exactly equals the number of the free variable. Okay, the number of the free variable. Each free variable we have a parameter. Okay, therefore this exactly equals the number of the parameters in the solution. Okay, and you see this should be the proof, right? So therefore we have meaning the nullity is just equals the number of the parameter in the general solution space of AX equals 0. Let me give you an example. Okay, I set up a homogeneous linear system. Let's say AX equals 0. Suppose A goes through the row operation, or like we use Gaussian elimination, right? We use Gaussian elimination. We find that the reduced root echelon is R. Let me give an example of R. Okay, so here is just an example. Look at this example. Now we have this is the leading one and this is the leading one, right? So two leading one. The original equation should be 1, 2, 3, 4, 5 column, 5 variables, and 3 equations at the original. So now we look at two leading one. Okay, so if this is x1, x2, x3, x4, and x5. So therefore, we find see these two leading variable, right? And these 3 should be free variable. So we have a 3 free variable. And we look at it. We think about what the rank of A, and the rank of A. Imagine the rank of A should be the dimension of the row space, and they see the first row and the second row should be form a basis. Therefore, the dimension of the row space should be 2, right? And the 2 exactly is the number of the leading variables. So that's the first result. The second was the nullity. Imagine the nullity. Nullity depends the solution space of Ax equals 0. And we have a 3 free variable. We can set up the 3 free variable as R, S, T. So therefore, okay, so we can get a basis. Okay, how many vectors in the basis? 3, because we have 3 variables. So the nullity should be equals 3. And this 3 exactly is the number of the free variable or the parameters. Okay, so that's all. Thank you.